Okay. The last part of this chapter, did you all get a pink note sheet? You don't need to do journals today. We'll do a little bit of vocab, it'll go on the back of the note sheet. The last part of this chapter is, will you be in class today?
Today, yeah.
What are you going to say?
Just use again.
I was out in next second, please.
Alright.
The rest of this chapter is over three-dimensional figures. Okay, so we're going to do surface area and we're going to do volume for about 5 different figures. So before we get into that, we're going to today just sort of get an introduction into the different components of three-dimensional figures. And you've seen three-dimensional figures before, like back in elementary school. You learned about like spheres and cylinders and some boxes probably. Now, real quick, what makes something a polygon? Let's review that real fast. So rather than, I guess, thinking about what makes something a polygon, let's think about what makes something not a polygon. So what would be something that, if it was there, would make something not a polygon? Luke?
Like the shape's not closed.
Okay. So polygons can have no gaps or openings.
360.
I understand where your brain is at, but that didn't make sense.
Like you can't.
It can't be round.
Yeah.
Just round.
No curves. No rounds. So circles are not polygons. Like arch shapes are not polygons, so on and so forth. Those are the biggest things. And then someone said earlier, polygons have to have at least how many sides?
3.
So they just have to have 3 or more sides. So today we're going to talk about three-dimensional polygons, which are called polyhedrons. So we're not dealing with spheres and cylinders. Those are three-dimensional shapes, but we're not dealing with them today. We'll get to those. But today is all about polyhedrons, which are essentially three-dimensional polygons. So you have some space in the back. We're just going to have, there'll be short vocab words today. But a polyhedron is a solid. You're going to hear or see the worksheet say solid a lot. A solid is a 3D figure. That's what a solid is. So a polyhedron is a three-dimensional polygon, so a solid bounded by different polygons. And then it has a bunch of different components here called faces, edges, and vertices. So I'm going to let you guys copy those down, and then I will give you a couple of visuals. Alex, you make sure your headphones out too, please. Thank you. Okay. So if I use up a couple of different visuals here, I unfortunately only have like rectangular prisms as examples, but if I were to use my recycling box as an example, your faces are the different things, like if I was holding the box that I could touch, so everything that makes up the box, so the front, the back, the right side, the left side, the bottom, and if it had a top, that would also be a face. So anything that you could touch on the outside that actually makes up the figure. All of your edges are exactly what you would assume edges are. Edges are where the different pieces meet. So like the left side and the bottom of the box meet right along this edge here. That would be an example of an edge. When we look at it two-dimensionally, you're going to see it as line segments. And then all of your vertices are all of your corner points where all of the edges meet. So this would be a vertex, this would be a vertex. On the bottom, there's some vertices. There's 4 on the bottom. There would be 4 on top. So same thing with my tissue box. This would be a polyhedron. All of the faces are what actually like make up the box. The edges are where the faces all intersect. And then the corner points are all of your vertices. Okay, but since we are looking at 3-dimensional figures on a 2-dimensional piece of paper, it can get a little more confusing because you don't physically have the object in your hand. But this is exactly what I just showed you in real life. Your faces are all the things that make up the box. All of your edges are these line segments where the faces meet. And then your vertices are all the different corner points. Okay, we good so far?
Wait, so the edges are like all of them, or like every line that's in the shape?
Okay, so edges, you have to picture this box physically in your hands. Like this would be an edge, but it's not like 2 separate edges, if that's what you're asking me.
So like, I thought like when you meant like edge, like, it was just like this one.
Edges are anywhere 2 faces would be meeting up with each other. So, what? Did you have more? Did you? Oh, were you drawing? Oh, I got you. Okay. So these first 3 problems say each figure is a polyhedron. The name of it doesn't really matter. State the number of faces, vertices, and edges each solid has. So I'll do the first one with you, and then I'll kind of let you guys guide the next 2. So faces are anything that actually make up the figure. This first shape is a triangular pyramid that has 1 face on the bottom, that's a triangle, and then 3 different triangles around the sides, making 4 faces altogether. 1 on the bottom, and we would have 3 around the sides. Vertices, you have 1 here, and 1 here, so 3 corner points along the bottom, and then 1 corner point on top, making 4 altogether. And then your edges, you have 3 along the bottom, and you would have 1, 2, 3 around the sides, making 6 altogether. So again, sometimes it gets a little bit confusing when you see lines intersecting, but that they're not literally intersecting. Like 3-dimensionally, this dashed line is down on the ground, and this line going up the side is pretty far away from it. They're not touching each other. It just looks like it because it's 2-dimensional. Second problem. Now this is a shape we're pretty familiar with. When we first learned about 3-dimensional figures, cube might have been one of the first ones you ever learned about. Who can raise their hand and tell me how many faces this cube would have? Corinne? 6. 4 along the sides, top, bottom. Vertices, who can raise their hand and tell me how many vertices it would have? How many corner points? Luke? 8. 4 along the bottom, 4 corner points on the bottom, and 4 corner points on the top. 8. And then your edges. Who can raise their hand and tell me how many edges it would have? Jake? 12. 4 along the top, 4 along the bottom, and he's right, 4 around the sides, making 12 altogether. And then this last one, it's like 2 pyramids glued together. Who can raise their hand and tell me how many faces it would have? The name of it kind of gives it away too. But 8. Now I get this question a lot, what about the one in the middle? If you were physically holding this thing in your hand, there would be 4 that you could touch on top and 4 you could touch on the bottom. You could not touch the middle. The middle is hollow. Even though it looks like a square, it's not actually a face on the figure. So there'd be 8 on top, 8 on the bottom. Vertices, who can raise their hand and tell me how many vertices it would have? Mia? 6. 4 around the sides, 1 on top, 1 on the bottom, And then raising your hand, tell me how many vertices it would have, or sorry, edges it would have, Jace. Say again. 12. 4 around the top, 4 right here in the middle, and then 4 around the bottom makes 12 altogether. Now, there's actually a pattern that goes along with this called Euler's theorem. We just don't cover it. We didn't cover it in our new books last year, and it's not terribly important. But just to give you guys a means of checking to see if your answers are correct, Euler's theorem says the number of faces no, that's wrong, sorry. The number of vertices. That was right. No, number of edges, there we go. Okay, I promise I'm right this time. The number of edges always equals the number of faces plus the number of vertices minus 2 every single time for any polyhedron. The number of edges that it has will always equal the number of faces plus the number of vertices minus 2. 4 plus 4 is 8, minus 2 is 6. 6 plus 8 is 14, minus 2 is 12. 8 plus 6 is 14, minus 2 is 12. So we used to cover Euler's theorem, but it's not terribly important as long as you can count. So, questions on that? Okay, let's go into naming polyhedrons. There are 2 different types of polyhedrons, but this slide shows you these are the 5 different types of, so solid, again, is really a fancy word for 3-dimensional figure. And we will go over 5 different kinds this chapter. So tomorrow we're going to do a whole section on prisms. Then Monday we're going to do a whole section on cylinders, and then on cones, and then on pyramids, and then on spheres. But for today's purposes, your polyhedra, which is plural for polyhedron, we're only looking at prisms and pyramids. So if you see one of these today, you would just write not a polyhedron. Now, the difference between prisms and pyramids, prisms have 2 bases, pyramids have 1. And I'm going to add to that for prisms, the lateral faces, meaning the ones that are not the bases, are always some kind of rectangle, possibly a square if it's a cube. And the lateral faces of a pyramid are always triangles. Okay, but prisms have 2 bases, pyramids have 1. Now, base is not a synonym for bottom. So the base does not have to be top and bottom. The base could be left and right. It could be in the front and the back. But prisms always have 2 bases, and pyramids always have 1. And then for pyramids, the rest of their sides all meet at a corner point, like a vertex. Now, naming polyhedrons, and this might be worth writing down somewhere, or jotting down somewhere. We name prisms and pyramids by the shape of their bases. Okay? So this first example is I know it's not on your sheet, but if you just put your eyes up here for a second. This first example is a prism. It has 2 different bases. Now, the base is, and I try to put this in the simplest terms, is whatever shape you have only 2 of. Those are your bases. So in this case, our bases are these pentagons. That's the only thing we have 2 of. So we would call this a pentagonal prism. It's a prism, and then the shape of its bases are pentagons. The second example is a pyramid, where the shape of the base is a triangle. So we would call it a triangular pyramid. Now you have to get a little creative here because you're trying to make nouns into adjectives like pentagon, ol. So in years past, if you need to just put like pentagon, prism, I'll know what you're talking about. Try and kind of make the noun an adjective if you can, but if you get stuck on like the ending of the word, don't worry too much about it. Okay, so these first three problems, first it says tell whether it's even a polyhedron. So I'm going to go ahead and give you a heads up on the third one. That third one's a cone. I don't want you to write cone. I want you to just write not a polyhedron. Or just even write no. No is fine. But for the purposes of this assignment, I don't want you to name that it's a cone. I know it's a cone, but it's not a polyhedron. A and B are polyhedrons. They have no curves in them. And it says if they are, name them. So this first one, first of all, is that going to be a prism or a pyramid? Alex? That one's going to be a prism. And the bases are what you only have two of. So these would be your bases, even though they're in the front and the back. And the shape of those bases is what? A rectangle. So this would be an example of a rectangular prism. So you can't just put box, right? I know it's a box, I got it, but that's elementary language. We're going to move forward from that. B, besides Alex this time, who can tell me if B is a prism or a pyramid? That one's a pyramid, and the shape of the bottom is a hexagon. So I think I heard someone just say a hexagonal pyramid. And then that third one's just not a polyhedron. You don't put cone, just not a polyhedron. Or put no. Not because it does say tell whether it's a polyhedron. Nope. Okay, the next three. Am I going too fast? Okay. This next one, first of all, somebody put that away, please. Let's go. DJ, is this first one a prism or a pyramid? Pyramid. And then be careful on the shape of the base because, and there's one on your homework like this, there are tick marks right there telling me that every side is the same. So what's the shape of that base? And I'll open that up to anybody. That's a square. Yeah. It is a rectangle, but it's more specifically a square because all four sides are the same. Number two. Andrew, is that a polyhedron, number two? No. Not a polyhedron. It's like a half cylinder, but it has curves in it, so not a polyhedron. And then the third one is a polyhedron. Let's go, Zach, prism or pyramid on number three? Prism. Has two bases. The bases are the only sides that or the shape that you only have two of. So what's the shape of our base here? Triangle. Yep. Mixed colors. So that'd be a triangular prism. Looks like a block of cheese. Questions on naming? Okay. Last little thing we have here is cross sections. Cross section is the intersection of a plane slicing through a solid. You don't need to write that definition down. Don't worry about that one. But if I were to take a knife and like cut through the three-dimensional figure and then open it up, the shape that it makes is what the cross section would be. So my example is an orange. Have you guys ever cut an orange in half? And when you cut the orange in half and pull it apart, what shape is the orange? It's a circle once you pull it apart. So they have the same shape here for each picture. This is not on your notes, but you have a perfectly square cube here, but they cut it in three different places, creating three different shapes. The first place they cut it is directly in the middle, and if they do that, and you were to cut the cube in half and then pull it apart, you would see squares. If they cut it at a diagonal, so if I have this and pretend it was a cube, if I cut it from here down on a diagonal to the bottom edge, and then pulled it apart, you would be looking at a rectangle. And then if I take the same cube and I cut it on the corner, like I just cut a little corner edge off here and pulled it apart, you would be looking at a triangle. Now they make it pretty simple here because they shade the cross section in purple, so it's kind of easier to see what it would be. But again, like I think of, okay, so here's my other example for you. A round cake. Have you guys ever had a round cake? Okay, if you cut the cake in half and pull it apart, what shape would it be that you're looking at? A rectangle, right? Even though it's a cylinder shape, like it's a round shape. If you cut a round cake in half, you really have cut the cross section to a rectangle. So this first one, A, if I cut that hexagonal prism in half, what shape would the cross section be? A hexagon. That's all it's asking. If you cut it, what's the cross section that you're seeing? B, if you take a triangular pyramid and cut the bottom off, Luke, what are you seeing? Triangle. C was kind of like my cake example. So if you take a cylinder and you cut it up and down and take a piece of it away, Luke's already answered. Thank you though, Luke. Alex? Rectangle is what I'm seeing. Even though it's a round shape.
What if the result like comes out round? That would you still say that was like,
It wouldn't though. Like if you, unless this cylinder had like a rounded top to it.
what if you cut it like the other way?
Oh, if you cut it in the middle, then it would be a circle.
Circle, it's not gonna-
Right. Oh, I got what you're saying. No, they're asking for the actual shape of the cross section. That was a great question. He's asking like, okay, like this one, would you put no or would you put what shape? I want you to put what shape it is. So when you cut the top of the cone off, what does it make? A circle. Yeah. I gotcha. This is not a yes or no question if it's a polyhedron. E was like my orange example. If you took an orange and you cut it in half, what shape does it make? Circle again. This one, I know they shaded it, but it's a little bit harder to imagine. So it's like they're taking this box and they're going to cut it on the corner edge here, but they're going to start in the middle of the box and then cut at a diagonal to a narrower part of the box. So if you start up at the top at a wider part of the box and then cut a diagonal to a narrower part, your bases are different shape or different sizes. And what shape would that be? Trapezoid. Very good. And we will work a little bit with trapezoids in the next section. You'll have to be able to find the area of one, but we'll review that when we get to it. Yep. So your worksheet's in the packet. Like I said, first hour, they got done. They got their answers checked. If you finish, I need it to be out in front of you so that I can check your answers. I'll be right back. But including announcements, you have 21 minutes. So there's really not a huge good excuse to, I can't speak proper grammar.